So this topic is about calculating the concentration of a hydronium ion and hydroxide ion. Okay, it's about the concentration. And as you know already, when we talk about a concentration of solution, we're talking about molarity or molality. In this case, the exercise is given to us the concentration of the acid in molar. Now, the steps we need to follow are these ones. In the first part, they are giving us an acid, okay? So in the first step, what we need to do is to work in the ionization of the acid. Okay? Now remember this. The ionization happens like this. You have your acid and you will combine it with water. The product will always be the same. Okay, one part of the products will always be the same, which is the hydronium ion. Now, this happens because imagine that you are getting rid of the hydrogen like that you are getting rid of the hydrogen to give it to the water, okay? So once you get rid of the hydrogen, the remaining is just NO3. NO3 is an ion that is named as nitrate, and it has a charge of -1. So the ionization of this acid will be hydronium ion and nitrate. Okay, after this, what we have to do is checking that the equation is balanced. Just compare the amounts of hydrogen, nitrogen, and oxygen in each side of the reaction. You have 1 plus 2 in this side, and in the other side you have 3. You have 1 against 1, and here you have 3 plus 1, and here you have 1 plus 3, which is the same. So in the end, the equation, as you can see, is already balanced. Because it is already balanced and you don't see any coefficient, the coefficient is going to be invisible 1. So it's going to be 1 here, 1 there, 1 here, and 1 there. Okay. After this, what we do is we're going to write the mole ratios of each part of the reaction. So for nitric acid, I have 1 mole of nitric acid. For water, I have 1 mole of water. For hydronium ion, I have 1 mole of hydronium ions. And for nitrate ion, I also have 1 mole of nitrate ion. That is going to be the first step. I repeat, you ionize the acid, you check that it's balanced, and then write the molar ratios. You write the number of moles of each compound that is in the reaction. That is part of the first step. Now, what you do in the second step is you're going to work on the concentration given. Now, the problem is given to us 1 times 10 to the -4th power molar concentration of nitric acid. Now, let's see what the molarity is. As you already know so far, molarity is, molarity has a formula that is established as molarity equal to the number of moles of solute divided by the liters of the solution. That is the equation that we use for molarity, okay? And after we apply it, we have the concentration in letter M. But the units that are making up the molar unit, molar, the letter M, is a compound unit. Now, let's see, molar. It is a compound unit where number of moles is above and numbers of moles are measured in moles, of course. And the liters of solution refers to the volume of the solution and is measured in liters. So in the end, this relationship is equal to 1 molar is equal to the number of moles divided by the liters of the solution. So in this second step, it's actually, you can do it in a single step, all of it, but it's just changing from molar to these units, okay, to mole per liter. So you're just going to substitute the M by mole per liters. So in the end, the concentration of nitric acid in this problem is going to be 1 times 10 to the negative 4th power moles over liter of nitric acid. In other words, the moles of nitric acid are going to be in the upper part from this relationship. Now that is the concentration. Once you have once you have got the moles per liter, you move into the third step. In the third step, we're going to get a concentration of hydroxide ions by using molar ratios. This is a stoichiometry. So, take a look. Let's analyze the word problem again. It says 1 times 10 to the negative 4th power molar solution of nitric acid. The given is the nitric acid. Okay, this is the given. And the problem is asking you about hydronium ion concentration and hydroxide ion concentration. Now, we're going to focus on the given and the unknown, mostly in the first part, okay? If I relate my nitric acid with my hydronium ion, I will be relating this part of the equation. My nitric acid here against my hydronium ion over there. So when I relate the two of them, I can obtain the molar ratios. The molar ratios are 1 mole of nitric acid produce 1 mole of hydronium ion. This is what we know as the molar ratios. Okay, so we're gonna be relating the number of moles of the given against the unknown. In the first part, the unknown is the hydronium ion, so we're going to focus on that. So we say we're going to obtain the concentration of hydronium ion by using molar ratios. So we always start with the given, but now this given, we're gonna use this relationship, okay? Remember, we already changed the units. So we're going to use the given, but with the units already changed. So in other words, we're going to start like this. 1 times 10 to the negative 4th power moles of nitric acid, all these divided by liters. Now, in the second part, I will multiply times the molar ratios. The molar ratios between the two substances, nitric acid and the unknown. Remember, this is the given and this is the unknown. Okay? So that is the relationship that I have to do in the reaction. We already established that the molar ratio between the two is invisible 1 against invisible 1, or 1 mole of nitric acid against 1 mole of hydronium ions. So we say, because my moles of nitric acid are in the upper part of the relationship, I'm going to write moles of nitric acid in the lower part. And since the relationship is 1 against 1, I'm just going to write 1 over here. Now, 1 mole of nitric acid produces 1 mole of hydronium ion. So that will be in the upper part. Now with this, we are able to cancel moles of nitric acid against moles of nitric acid. As a result, you're going to obtain the same number, since you're multiplying times 1 and dividing by 1. But the units are changed. Now I have moles of hydronium ion per liter. Okay? These are the units remaining. Moles of hydronium ion in the top and liters below. Now let's go back and analyze this. Moles per liter are the same molar. Okay? So this means that this is the concentration of hydronium ions. And when we talk about concentration of ions, we can also express the answer like this. Both are correct. Both represent the same thing. Again, I repeat, because these are moles per liter, we are talking about molar. Molar indicates concentration. Remember this. Molar indicates concentration. And the problem is asking me about the concentration of hydronium ions. So here what we could do is replacing the moles per liter by the letter M that represents concentration. You can write it like that too, okay? But the best way to do it is like this. Why is that the best way to do it? In chemistry, these brackets that are holding the hydronium ion inside, those brackets tells you that what you are getting over there is concentration. So this is the way that we write it, but both ways are correct. This is like the more professional way. So that's why this is the answer that I will highlight. But either way is fine, okay? Either way is fine. It doesn't mean that if you leave it in molar, it's going to be incorrect. No, it doesn't mean that. Now, with this, we already solved the first part of the problem, which is calculating the concentration. Remember, the brackets mean concentration of hydronium ion of this solution is already solved. Now we're going to focus on the second part that says calculate the OH, the concentration of OH ion of this solution. So for this step, we're gonna need one formula. So in this fourth step, I'm going to get the concentration of hydroxide ions. Now, I'm giving you a table and a formula. Take a look. This formula says Kw equals hydronium concentration times hydroxide concentration equals to this number. Now, this number is coming from the table. Why am I highlighting those numbers, those values? Why the temperature of 25 Celsius is so important for this topic? Does the 25 degrees tell you something or remind you of something?
It's not room temperature.
Exactly, it is the room temperature. Thank you. 25 degrees Celsius is known as the room temperature. It's like the ideal temperature for things to happen. I don't know if you have read the I don't know, some medicines. In the labels, you can read store this medicine uh, at 25 degrees Celsius or a lower temperature. That is because a higher temperature um, rottens the things. I mean, if you want to preserve something, you use the freezer. Okay, if I want to preserve meat, for example, I will use the freezer because a lower temperature allows me to preserve the meat. Okay, so the room temperature is important because here in the problem it's telling you that this solution is being prepared for a laboratory experiment. In a chemistry lab, in a chemistry lab, um, the chemist is gonna try or is going to set up the temperature of the air conditioner to 25 degrees. The reason is because that is known as the room temperature. Room temperature allows reaction to occur in the ideal way. So because this is a laboratory experiment, we need to expect that the temperature in that lab is going to be 25 degrees. 50 degrees, you would melt with 50 degrees. And a lower degrees, some substances would freeze. Okay, so the ideal temperature is known as the room temperature. And that's why the Kw that is being used here is this one. 1 times 10 to the negative 14 power. Now, I can just tell you, use that always, and you'll be fine, and that will be correct. But I want you to know where the things are coming from. So, I'm going to take this equation, and I will isolate for the hydroxide ion concentration. So take a look. My hydroxide ion concentration is going to be equal to, okay, this is the Kw, okay, and the Kw is equal to 1 times 10 to the negative 14 power. Now, this is multiplying the OH, which means that when you send it to the other side of the equation, we'll be doing a division. So, the formula for the hydroxide ion concentration is going to be 1 times 10 to the negative 14 power divided by the concentration of hydronium ion. The concentration of hydronium ion is the one that we got in the step before, which is this one. Now, what we're going to do is we're going to substitute. So we say OH minus concentration is going to be equal to 1 times 10 to the negative 14 power divided by 1 times 10 to the negative 4th power. How much do you get from that?
One times 10 to the negative 10 power.
1 times 10 to the negative 10th power. And with this, you solve the problem. As I told you professionally, we we understand that the brackets indicate concentration. Also here in the formula, as you can see, the concentrations are in brackets. That's why we continue like this. Now, let's see this problem. This problem I did it mentally. In 2 seconds, I did it already. But not all the problems are going to be this easy. What is the first step that we need to do with the acid?
What is the net ionic equation?
Writing the ionization equation. So in the first step, we have the ionization of the acid. I'm not going to write ionization because of the time. So it's going to be HCl. I will combine it with what to do the ionization? Ionization involves water, okay? So you are combining HCl and water. Now the product is always going to be hydronium ion, and the other product is going to be the acid with the H, which is going to be just chlorine. But chlorine not as a single element, but as an ion. It's going to be like that. Is the equation already balanced? Is it balanced?
Yes.
Yes, it is balanced. If it's already balanced, means that
Miss,
the coefficients are going to be 1. Tell me.
why you don't put chlorine as an atomic element?
Because in the ionization, okay, the name ionization comes from the word ion, okay? And the ions have charges. All ions have charges. So, for example, nitrate ion has a charge of -1. Hydronium ion has a charge of +1. Ammonium ion has a charge of +1. Because we are ionizing the acid, we're going to obtain the ions that are making up the acid. In this case, the ion is chloride ion, not chlorine as an element. Okay, so we write the ion. So it's going to be chlorine with a coefficient of 1 over there. As you can see, it's already balanced. So the molar ratios, the molar relationships are going to be 1 mole in all. After you do the number of moles, you need to change the concentration units. So instead of writing 1 times 10 to the -4th power m HCl is going to be switched into 1 times 10 to the -4th power. Instead of m, you're going to write moles over liter of the acid HCl. That is the second step, changing the units for the concentration. In the third step, we're going to get the hydronium concentration by using molar ratios. And what is the molar ratio between the acid and the hydronium ion?
1 and 1.
1 against 1. 1 against 1. Okay? So, I'm going to start by writing the concentration here. And I will multiply times the molar ratio. My moles of hydrochloric acid must be below. And the moles of hydronium in the top.
Means, but the answer will be the same, right? Because
Exactly, I
the
told you. I told you in the beginning. I did it in 2 seconds. Because the given was the exact same than the one that we did. But it's not always going to be this easy. So the